What was the role of satellites in IGY polar missions? Imagine a time when scientists had no way to see the vast, icy expanses of the polar regions from space. That all changed during the International Geophysical Year, or IGY, which took place from 1957 to 1958. Satellites played a key part in this scientific push to understand Earth's most remote areas. Before satellites, most research in the Arctic and Antarctic relied on ships, planes, and ground stations. These methods were slow, limited in reach, and often couldn't gather data from the most inaccessible spots. The launch of the first artificial satellites, like the Soviet Union's Sputnik 1 in October 1957 and the United States Explorer 1 in 1958, marked a new era. These satellites allowed scientists to observe Earth's polar regions from space, giving a continuous view that was impossible before. They collected data on atmospheric conditions, solar radiation, cosmic rays, and Earth's magnetic field. This information was especially important in the polar zones because of phenomena like the aurora and the behavior of the ionosphere. Satellites helped scientists understand how solar activity impacts Earth's environment, especially at high latitudes. They worked alongside ground stations in the Arctic and Antarctic, which gathered local data on weather, ice, and geophysical processes. Satellites provided a broader picture, helping map ice cover, track weather patterns, and see how polar regions connect to the rest of the planet. For example, satellite data confirmed the existence of the Van Allen radiation belts, regions of charged particles trapped by Earth's magnetic field. These belts influence space, weather, and auroras in the polar zones. Satellites also improved communication and navigation for polar explorers. Real-time data from space meant better weather forecasts and safer expeditions in harsh environments. Over time, satellite technology became a standard part of polar research, helping scientists monitor climate change and ice melt. The use of satellites during the IGY showed how international cooperation could push science forward even during tense political times. Today, Earth-observing satellites continue to track polar ice, climate shifts, and environmental changes, building on the foundation laid during the IGY. These space tools transformed how we study and protect Earth's most extreme regions.